Thanks for coming. I'm Brad Lindsley. I'm a Lamont research professor, and I'm here to welcome you to the Future of Our Oceans event. So thanks for coming. I work at Lamont-Doherty Earth Observatory. If you haven't been there, it's up in Palisades, New York. I run a geochemistry lab, and I also co-direct the MS in Sustainability Science program here on campus, and I teach a class in marine and estuary systems every spring. I love the ocean. I grew up in Connecticut, in Guilford, on the Long Island Sound, playing in the marsh grasses and the sand, and became amazed by how sands moved. And I got interested in paleo-environmental analysis long before climate change was a hot or sexy or dangerous topic. So most of my career now is focused, my research now is focused on using large corals to reconstruct climate. Corals have annual growth rings in them, and we can sample them down vertically. And some of these coral colonies are 300, 400, 500 years old, and we can sample them at almost monthly resolution. It's quite remarkable, and I got fascinated by it. And so we measure geochemical tracers to reconstruct temperature and salinity, and rainfall, and river discharge, and carbon dioxide uptake by the ocean. And so this work I didn't plan on it, but it's taken me to all these remote places across the Pacific. I've worked in the Cook Islands, in Fiji, in Tonga, American Samoa, the Great Barrier Reef, worked in the Sulu Sea in the Philippines, and Indonesia, the Line Islands in the middle of the Pacific. Currently working in Panama. I worked also in one of the most remote places I've ever been, and that's Clipperton Atoll, which is a French coral island off the coast of Mexico in the Eastern Pacific. So these amazing places all have, unfortunately, one thing, or several things in common, one of which is they're all covered with plastic debris, plastic waste, stuck in the roots of grasses and the corals, stuck in mangrove roots. They also have a lot of evidence of coral degradation. I've seen some reefs are in really bad shape, others not so bad. So only 20 years ago, I was in Tonga, in the Minister of the Environment's office, in the Kingdom of Tonga, trying to get a reef research permit. And I had done a little diving around, and I noticed the reefs are all around Tonga are all in pretty bad shape around this main island. It's the southern end of Tonga. And I asked the minister, why are the reefs in such bad shape? And he looked at me and said, oh, dynamite fishing. And that's when they throw dynamite in the water to kill the fish, and they float to the surface, and they scoop them up. So we have a lot of educating to do, and a lot of complicated issues around this, because these fishermen were doing this to feed their families, some of them probably. And we have to navigate that kind of thing with reef health. Closer to home, we also have, I think, some pretty serious misconceptions in this country and other places about what evidence is for global and regional climate change. And so I've been to several events over my life, or most recently, and maybe you too, where you start talking to someone you just met who seems to be well educated, and all of a sudden the topic drifts around to climate change, and they ask, do you believe in climate change? And so I'm really taken back by that, because the word believe is something that really bothers me, because it's not a belief. We're scientists, we look at data. There's a lot of data showing that climate does change. The fact that scientists like us are simply voicing our opinion, well, that's just not what we do. And somehow it's gotten into the press and in the public conception that that we are making it, or just voicing our opinion. So, and I'm not quite sure how to respond to that. Do I tell them, oh, well, it's already 1.5 degrees warmer than it was pre-industrial, and it's going to be 3 degrees warmer in 75 years for my kids, and the sea level's rising 4 millimeters a year off the coast here, and you add that up over 100 years, we're going to have a lot of coastal problems. So we need to, I think, push back on the word believe, all of us, not just me, everyone here. I mean, when someone asks you, it's not a belief. We're actually basing our judgment on data. There's all sorts of data, plethora of data out there. Anyway, so enough of my rant, so thank you. So this evening's event is a collaboration between the MS in Sustainability Science program, which I co-direct, and also the MS in Sustainability Management, as well as the Coral Reef Restoration Consortium and the Woodsell Oceanographic Institution. And it's my pleasure to introduce Sonya Dyhrman. She's a professor of the Earth and Environmental Sciences at Columbia and also a Lamont scientist in the same division I'm in, biology and paleoenvironment. And her specialty is using geometric approaches to study microbes in the ocean. It's quite fascinating. And so I look forward to the discussion this evening, and thank you for coming.
Thank you, Brad, and good evening, everyone. It's now my pleasure to get to introduce our panelists tonight. So at my far left here is Dr. Ajit Subramaniam. Ajit is a Lamont research professor at Columbia's Lamont-Doherty Earth Observatory. And he is a microbial oceanographer, like myself, with expertise in biogeochemical cycles, remote sensing, biooptics, and phytoplankton physiology. He's interested in advancing our ability to observe the ocean and in expanding our understanding of how the marine ecosystem works and is managed, sustainably managed. He currently serves on the National Academy of Sciences panel for the Decadal Survey of Ocean Sciences and is a sustaining fellow for the Association for the Sciences of Limnology and Oceanography. Next to him, we have Tali Vardi. She is Executive Director of the Coral Restoration Consortium, or CRC. The CRC is a global community of practice for the field of coral restoration, connecting scientists and practitioners and really providing a gold standard product to move the field forward. She's really an international leader in the fields of habitat restoration, coral reef ecology, and intervention science, as well as international policy, advocacy, and community building. And then last, we have Richard Vevers, who is director of Room 71, a novel communication initiative from the Woods Hole Oceanographic Institution. Richard is a fellow in the Explorers Club and is best known for his leading role in the Emmy award-winning documentary Chasing Coral on Netflix. I suggest everyone watch it. His work has been featured in numerous publications and documentaries, and I understand his imagery revealing what is happening to our oceans is some of the most viewed underwater imagery of all time. And his ideas, projects, and public speaking have, again, made him a leading voice in the fight to save coral reefs and protect our oceans. So with that, I would like to get started this evening. And really, I just gave you this introduction of their bios, and I think I would suspect that all of us have been interested in marine science to some degree for a long time. Me, since I was a kid growing up in the Puget Sound area of Washington and getting to muck around in tide pools and learning how to scuba dive before I even got my driver's license. But let's hear from our panelists. Maybe about one thing that inspired you to pursue work in marine science.
Well, I think I've got quite an unusual story of how I got into ocean science. It was, I was in advertising for 10 years, very stressful job, and then I had an incredibly bad meeting one day. I think we were talking about toilet tissue. It was getting very heated, and I thought, that's it, I've had enough. And I decided I needed to go to my happy place, which is the ocean. I've always loved the ocean, and I decided that was going to be my new permanent career. So I then became an underwater photographer, and it led me on this sort of real adventure and led me into ocean science.
Thank you.
Yeah, well, I grew up swimming in pools in New Jersey. Where there is not a ton of life. And it was really in my early 20s when I started traveling around that I really got introduced to the whole concept of conservation and the fact that species were going extinct. And I kind of instantly became this kind of bleeding heart environmentalist. And at some point I realized, wow, I wonder if I could swim and also do conservation at the same time. And I didn't even know there was a field of marine conservation biology. And once I did, and I learned about the existence of coral reefs, it was really a no-brainer for me, because coral reefs have the most bang for your buck if you're trying to save organisms. There's just the most on a coral reef. So I got to combine kind of all the things that I wanted. That's my trajectory.
I grew up in a small town in South India, small relative, it's 1.2 million people. It was sort of equidistant to the ocean. It was a landlocked town, about 100 miles in any direction to the ocean. So I wanted to be an oceanographer. It was at one level how I left my town, which is something I was eager to do. But actually, it was really tempered by the fact that I was a very avid reader of science fiction. I don't know, out here, I don't know, not too many people have heard about it, but I used to devour these books of adventures by this teenage group of kids, Tom Swift and his colleagues, who went everywhere and basically explored the universe, really speaking. But they had a lot of underwater adventures, and it seemed to me that that's sort of what I wanted to do, study the Earth in its entirety without falling into a particular silo if I'm going to be a physicist or a chemist or something like that. And oceanography basically compels you to understand the system as a whole. So it's sort of something that I fell into without really knowing. I didn't know what oceanography was till I sat and took my first graduate class. But that's what I wanted to be since I was about 10 years old. And here I am.
Mm-hmm. Thank you. So just again, to get started here, I think we maybe all think of some common things when we think of the ocean. We just heard about coral reefs and beaches, and we look out into the ocean, and maybe you've gone whale watching, or you really love seafood, and so you think about the ocean and its importance for food. But as experts, what are some of the roles of the ocean or ocean life that are important that you think about that maybe aren't on radar quite the same way?
Who would you like to start?
Yeah. Richard, why don't you start?
Okay. Well, I mean, again, I come at this from sort of the marketing side and the communication side, and it's been a huge learning curve since I sort of did this career change and got into, initially coral reef conservation. But I'm constantly learning about the importance of the ocean. And recently I joined Woods Hole Oceanographic Institution, which is the world's leading independent oceanographic institution. And that's where I've suddenly realized I knew nothing before I started speaking to the scientists there. There's this phenomenon that I've sort of recently sort of understood, which is ocean blindness. We have this terrestrial view of our world, and we cannot see the reality of the ocean. We think about it using terrestrial thinking. And it's very difficult to understand the importance. So when you hear about the importance of the ocean, often you don't believe it. Coming back to that point, it is actually a belief system that you're looking at the ocean and it's not making sense that it's that important. And so what we've been trying to do is try to reintroduce people to the ocean. And I've got a little prop which I use just to sort of explain, because the ocean isn't what you imagine. It's not that blue ocean you tend to see from shore. It's actually black. This is obsidian, which is lava rock that comes out of sea vents, and when it hits ocean at that freezing temperature under pressure, it turns into this lava glass. And we use this to explain the ocean, because the ocean it's heavy, it's black. We normally freeze it, so it's freezing cold, and then it's three-dimensional, and that's really important because it's this massive space. We think of environments in terms of areas, but it's actually volume, and it's an extraordinarily difficult environment to live in, which makes the life that lives there extraordinary to be able to cope. So you've got animals that can live for 16,000 years and have the most unbelievable immune system on the planet, like the glass sponges, for example. And then it's the enormity of life. A single litre of ocean, which this would be, would contain billions of life forms, and that's all interacting as part of the climate system. and some have tens of billions. And so we underestimate the value and the extraordinary nature of ocean life compared with terrestrial life, and then we underestimate its abundance, and those would be the two key things.
I think maybe we're all thinking about this a little differently now. Tali, would you like to share something from your perspective?
Sure. So when I started my PhD program and I went to study coral reefs in particular, my PhD advisor really said, you know, it's all about the people. And I thought I had landed in the wrong place because I came there wanting to, you know, save as many of these billions of organisms that I possibly could, knowing that many of the organisms in reefs and in other places in the oceans aren't even known, right? So we're losing things that we don't even know, and how terrifying that is from, you know, we must do something, right? That was my mantra. But what I learned more recently, really focusing on coral reefs and restoration, are the people that have relied on these reefs for tens of thousands of years in places like throughout the Pacific in particular. So like traditional owners in Australia and Papua New Guinea have lived there for 50,000 years. That's the human history. And they have a whole cultures and languages that really revolve around coral reefs. And these places, because reefs are so threatened, and the whole cultures are threatened, and we're losing like 9 languages a year at this point. And there are these like perfect example is the Hawaiian kind of origin story. Koa is a coral polyp, right? Their whole origin story, it comes from coral reefs. So we have these kind of, or I at least had these Western notions of, oh, coral reefs are pretty and I love to swim in the ocean, but for so many people, these are really this is their entire culture, and that is what's threatened along with all the organisms. So that's something kind of new and newly important that really drives a lot of my work.
I guess I'm sort of driven by just needing to understand, but I kind of put it into 2 bins. I have food for the stomach and food for the brain, which basically loosely translates to much of the work that I do is driven by intellectual curiosity, and some of the work that I do is because there's an actual application. And it's never clear that which path it's going to land up in. Just as an example, we've been for almost now 30 years looking at the outflow of the Amazon River, where it comes into the Western tropical Atlantic. Just some facts, just to put it out there. The fresh water that comes out of the Amazon River spreads over an area that's greater than 1 million square kilometers. That's almost the size of the Gulf of Mexico for a few months of the year. So it covers a huge area, impacts a large part of the ocean in that part of the world. When we were studying it, we were just studying how does the Amazon River outflow impact the ocean, not because there was a particular point that we were trying to get to. And yet, because we've been doing this for as long as we have, more recently, when we started seeing massive amounts of sargassum wash up on the islands in the Caribbean, in Mexico, in Belize, when there is some sense that it might be attached to the Amazon River outflow and changes in the Amazon basin, we can dig into our data and the research we've been doing over all this time to basically say, well, we are seeing some changes, but these kinds of linkages are a lot more complicated and not as simple as someone cut a tree there and therefore you have a sargassum massively washing up on a beach somewhere else, right? So we didn't, and when we started doing the research, it wasn't because we were trying to answer a particular question, but the research that we did helps answer a question. The flip of that is I work with a community in Alaska, a remote community north of the Arctic Circle, in a village called Kotzebue, where the folks there who live, the community that lives there, gets about 70% of their protein from subsistence from the waters around the place where they live. It's in the form of fish, seals, and whales. And they're really concerned about climate change and how it is going to change the base of the food web and how that's going to propagate up to the things that they value for spiritual and food sovereignty needs. And so in working with them and trying to understand how the phytoplankton are changing there, it is approaching it with a very specific question in mind, but very quickly that sort of turns into a more basic sense of, okay, they're interested in toxic cyanobacteria, but to understand toxic cyanobacteria, we need to understand the system. So you had kind of pulled back to more of a fundamental research question that you need to understand before you can answer a specific applied question. So these are kinds of the tensions that tensions, it sounds very dramatic, it's not really a tension, but these are the sort of the push and pull that I work with in how I study the ocean.
I feel like some of the factors that I think about too are the ocean's role in modulating weather and climate, and the fact that the ocean is a major sink for CO2. Without the ocean, we would have a lot more CO2 in the atmosphere. And I think about the role of microbes, since that's my area of expertise, in driving CO2 out of the atmosphere and into the ocean. In fact, they move about 50 billion tons of carbon a year into the ocean, this vast, invisible world. And all of these different factors, I feel like, aren't always on radar, but we appreciate that they're important culturally, from the fish that you want to eat to what the weather's like and what's going to happen in the future for our families in the next generation. And maybe you could then elaborate, now that we've heard about all these important things. We've touched on it a little bit, but the ocean is changing, the planet is changing, and I'm wondering, again, from your perspectives, what do you think the big concerns are in terms of thinking about ocean change?
Well, I'd say, there's three really big issues that everyone talks about. One is ocean warming. That's the biggie. Then you've got pollution. Then you've got overfishing. It's the warming that keeps me up at night because of working on coral reefs for so long. This is the warming is at such an alarming rate that it's now threatening an entire ecosystem. And we've never really said that before, that we could lose an ecosystem. And this is an ecosystem of over 1 million species. So it's not like losing a species on land. This is sort of the impacts in the ocean are just unbelievable in their scale. Coral reefs support about a quarter of all marine life. So if you lose that ecosystem, it has huge knock-on effects. And then we're already sort of seeing the changes in currents that ocean warming could have, and that has just unbelievable implications. But what is a big concern for me is this ocean blindness and the fact that we are not focused enough on the ocean. It's really sort of getting into the debate in terms of climate to the degree that it should. There's this great layer of life in the ocean, in the twilight zone, where 70% of the animals on the planet live, and people haven't even heard of it. And they haven't heard of the key species that are part of the climate system, like salps that clone themselves, etc. So we're not focused enough on the ocean, and we need to be.
I would just say that the ocean is going to be fine. It's us. It's how much tolerance we have for the uncertainty. I mean, we'll lose species for sure. We might lose ecosystems, but how much tolerance do people have for the types of weather uncertainties that are happening? How much tolerance do we have for losing cultures and for the amount of climate refugees that will occur and resettling them, and how expensive all that stuff is? And I think we see what kind of tolerance we have. It's kind of a failure of the human imagination to plan for, even 5 years ahead, right? So I think that to me is how I think about it, because the ocean will still be here, but who knows about us?
I'm just going to pick up on those two points, because so the project I do in Alaska I call making the invisible visible, because I'm working with microbes and trying to sort of share this idea that that's the base of the food web, and changes to that system will percolate up to something that you actually care about. But as you say, microbes basically are turning over on every couple of days, every day, really rapidly, and they evolve. They evolve really fast. So they'll do all right. I mean, most of them will do all right. It's the impact on us that we really worry about. So in the Arctic, you now have toxic microbes that didn't exist before as a consequence of climate change. And I feel that what I would like to do, or what I basically think about all the time, is how do you connect these dots to make it more visible to people? How do you uncover them in a way that people sort of appreciate all that's going on? Because all we can see is a storm that basically floods a coastal land, or for that matter, somewhere deep inland. But how do you connect the dots to understand consequences that we face on a daily basis? So, in other words, we don't have to wait to see what's happening, because it's happening right now. And so then, okay, it's happening. What are we going to do about it? And it's those dots and how you connect them is where I spend a lot of my time trying to figure out.
That kind of comes back to ocean blindness a little bit for me too, and thinking about how do we instill the importance of the ocean, the ecosystems, and the different roles it serves. I mean, one thing that I think about in that space too, in terms of changes that isn't always obvious, are the changes in ocean chemistry. As you put more CO2 into the water, it changes the chemistry of the water, and the ocean is in fact becoming more acidic. And that has influences on corals, it has influences on other things that biomineralize, and it changes sort of who's there and what they're doing in terms of the microbes at the base of the food web. And so again, how those things expand out is an area of uncertainty.
And I love that conversation we had earlier, just on these microbes that talk to each other with chemicals. And it's this, once you realize that ocean life is extraordinary, you get sucked into it. And that's when you realize the potential of the ocean to solve our challenges. It's just constantly at Woods Hole, I'm finding out sort of these new discoveries that really leave me with some optimism about the future, because we're not really looking at the opportunities at the moment.
One of the things that we talk about in the Columbia Ecosystems class that I teach in is thinking about the carbon cycle in the ocean and climate mitigation strategies. And I think one of the challenges for the ocean is that it is both a stakeholder and a player in what happens next. And the fact of the matter is the ocean is a very large reservoir for carbon. It's dutifully trying to stay in equilibrium with the atmosphere and take up all of that carbon we're putting into the atmosphere. And there's a lot of interest in could we manage the ocean to try to take up more carbon and help out the climate problem. But again, you have to manage that with sustainability and ocean protection as well. I'm wondering, Ajit, do you have any perspectives on this? Actually, I know Ajit has some perspectives on this that you might want to share.
Yes. So first thing I want to make really, really clear is that mitigation strategies are sort of kind of just that. If you don't reduce emissions, nothing else matters. We simply cannot mitigate away if we keep emitting. So I do want to really emphasize the fact that reducing emissions is the first goal. While in the process of doing that, what else can we do? That's the only way in which I can frame any kind of carbon removal, which is if you don't reduce emissions, no point in talking about the rest of it. But then, given that the oceans cover 70% of the Earth's surface, it seems like a fairly obvious target, if you will, for removing the carbon. It's already doing that. The ocean's basically taking up anthropogenic carbon, which is what is causing the ocean acidification problem. What can we do to geoengineer that? Now, just want to put it as a perspective. When we talk about geoengineering, lots of folks, people's hair stands up, hackles go up, understandable. I'm not very comfortable with that concept myself. But it is useful to recognize that what we're doing right now is geoengineering, because we are putting out carbon dioxide in the atmosphere every day. So turning a blind eye to it is not going to help us very much. So we're going to do something about it. Again, we've got to reduce emissions. Geoengineering is not going to get us out of the hole we are in. It's just going to make the hole ever so tiny bit shallower. But we're still digging the hole. So what can we do in the oceans? This, for me, is a fundamental question. There's already a market that's taken off. And this is one of the places where I'm really worried that instead of this idea and the concept and what we do being driven by science, it is going to be driven by the market. And from where I sit, it's potentially an ideological position, but from where I sit, if you don't have science driving it, and instead market forces driving it without the science, we will have bigger problems. So what I've been thinking about is how do we get ahead of that? What can we say about how do we figure out what is safe? Even with the market, how do we know we're even doing it? I mean, there have been news, I don't know if you keep up with this is something I obsess about, news about, you have credit cards that offer you a cent of, every dollar you spend, a cent is going to go plant a tree somewhere. And we have no idea how effective, any of those are to actually saving the planet, right? But that's how it is sold. We need to know how effective some of these ideas people are putting forward are. They may work. It's not to say they won't work, but we need to know how they work for them to be actually effective in the market. So even if you're going with the market force, we need to understand the science behind it that will drive how this works. Because the market needs to trust what you're doing. So there are a lot of really important questions with marine carbon dioxide removal. And doing it in the ocean is hard, because observing things in the ocean is hard, measuring things in the ocean is hard. So these are some really fundamental challenges that I think as scientists we need to step up to, and as humanity we need to understand better before we launch into them.
I guess leaning into that, I think one of the challenges here when it comes to the ocean is who gets to decide, right? I mean, it's the ocean. I feel like that's one of the real challenges. A number of us, I believe, have been to UN-sponsored either biodiversity or climate conference of party meetings, COP meetings. I had the privilege of getting to go and speak in a blue carbon panel at the COP27 in Egypt, and that was actually through the Ocean Pavilion. Now, if you haven't been to COP, it's a bunch of stakeholders, so nations, NGOs, all set up these pavilions and do programming in conjunction with the negotiations. And this COP27, so 27 COPs have happened. COP27 was the very first time the ocean had a pavilion even to try to represent it as a stakeholder in what happens next with climate, and that was through leadership from Scripps and Woods Hole. And just reflecting on that and this idea of who gets to decide when we're talking about policies, geoengineering, I'd love to hear from you all if you feel like the effort is working, if the policies are moving the needle. We have a non-ratified high seas treaty. There's the 30 by 30 idea. Maybe you'd like to reflect on that.
Yeah, I was there at COP27, and that was the first time they'd even had an ocean pavilion, yeah. Where you could change the name of climate change to ocean change because it is fundamentally an ocean issue. It's just crazy that there hadn't been an ocean pavilion before that. And it hadn't really been a core part of the negotiations. So we've got a long, long way to go. There's the UN Ocean Conference next year. It's only the third one. There just isn't the policymakers putting any real attention on the oceans at this stage, and certainly not to the level they need to. Again, because of this ocean blindness, in my opinion. But there's the SDG goals, the Sustainable Development Goals of the UN. Ocean is always last in funding, in what policymakers feel is important, and that's because of lack of understanding of the ocean's importance and its potential. And that's a communication issue that we need to address, and need to address very quickly.
Tali, with all your work in conservation and restoration, I'd love to hear your perspectives on this.
Yeah, I think it's really easy to say no, the policies aren't working, and from the place that I come from, I always want more, right? I always want more conservation, more, everything protected. But I think it's also very important to see where we would be without certain things like the ESA, like the Coral Conservation Act, like, at least we've had 3 ocean pavilions there's one happening right now at COP. And so I think, one place you can look even as fisheries regulations in the United States. Fisheries are regulated now better than they ever have been, and while it is true that our fisheries are at low stages, they are managed really well, and that wasn't really the case even 10 or 15 years ago. So I think it's really important to also look at our successes. It's hard to manage things in the ocean. It's hard to manage what you can't see. There has been a tragedy of the commons for our entire evolutionary existence on this planet. And so I think the ocean now is kind of coming into its own in terms of being a stakeholder and advocating for itself with, via our voices and others. But it's definitely an uphill battle.
And it roars. When it's not heard, you
Yes.
have Asheville, North Carolina underwater.
Yes.
Okay, sorry, not to make a joke of it. No, really, that is serious. But anyway, the thing is that you think you're safe far away, but ocean impacts are felt very far from the shoreline. But to this question of who decides, I think that's so. I've sort of, it's not to play word games or get all semantic about it, but I've sort of, in the last few years working in the Arctic, stepped a little bit away from conservation and think more in terms of stewardship. Because for me, there you have the people who are most impacted actually playing the leading role in protecting what's around them. And this is basically where I will confess that I'm quite a bit challenged by a notion like 30 by 30, where if you don't have the people who actually inhabit those places having a voice in what's happening, then it's not particularly sustainable.
Yeah.
And so for me, it's when something is imposed from above, it really doesn't sit well, mostly because it probably doesn't work. And so if you really want it to work, you need to get the people who are actually impacted involved in the process, and that has not always been the case. It is probably getting better, but it's all really complicated. The community that I work with are in the Arctic are impacted by climate change. Their houses are literally falling apart under them with the thawing of the permafrost. I mean, the houses are falling apart. The sea ice is disappearing. Their way of life has changed. People die because the sea ice is not thick enough to support, and they crash and fall through. But they also have oil exploration, and in my mind, it's sort of been very hard to sort of wrap it around the idea that they will work in an oil rig and they care about the environment at the same time. And I've talked to some of the elders, and they're like, you created the problem and we have to sacrifice twice over because we don't have a job and our houses are falling apart, right? So it's like, fix your house and then come and tell us what to do. Now, that's very simplistic in my mind, in the sense that my understanding of it is very simplistic, not what they say. My understanding of it is very simplistic. But for me, these are sort of the conundrums I sort of struggle with, as in, who am I to go tell somebody there that this is what you should do, right? Without them sort of involved in the conversation. So to your question of, who gets to decide, these are complicated. We have rules. I mean, I was just talking to a friend back before this meeting at the back of the room. We have the UN Convention on Biodiversity Beyond National Jurisdiction, BBNJ, beyond,
Yep.
yeah, right?
Yeah.
Yeah. And as a scientist, it's a little bit it complicates my life. I cannot go where I want to and sample the water for the microbes that I'm interested in to see who's in the water and how they're working, which is a curiosity-driven science to understand how the system works. But at the same time, history is rife with people going and taking something that doesn't belong to them and claiming it. This is going to be we are dealing with this with deep sea mining. Who gets to decide and who gets to profit? So for me, these are all things that I don't think are settled in my head, but things that we really should be talking about in fora like this.
Yeah, I just want to build on that for 1 second. So it's so true what you say, and the traditional landholders who have lived on these coasts and used the ocean for their own culture and sustainability for thousands, sometimes tens of thousands of years, those are the stakeholders. And you asked who gets to decide, and I mean, for the past 200 years, they have not been able to decide. And they're coral reefs are these very cool, it's a cool thing to work on because it's very intersectional, because they're a rock, they're a plant, they're an animal, they are culture, they're everything. And there is quite a push right now in the Pacific Islands for recognizing these cultures and these stakeholders. But it's kind of an 11th hour type of thing. But I do think that it is increasingly being recognized, and those cultures are being recognized as stakeholders.
And you've all reflected on the importance of community engagement in sustainability, conservation, restoration efforts, and stewardship. How do we expand on that? So take that element and broaden it so that we all find a role for engaging in that way.
Vote. Vote, go into nature, and volunteer. Those are my 3 recommendations to all of you.
I wish voting solved our problems, but moving right along. For me, it's some elements of education. When I talk about communities need to be involved, I don't think that absolves us of our own responsibilities. It isn't that because they're going to be in charge and they're going to make the decisions, we don't do anything about it. So knowing sort of what we do and everyday consequences of what we do is a key part of, for me, looking at the whole system. I think that just trying to raise voices of the people who are impacted is probably the most important thing. We all are, so we all have a role to play, but some more than others, and that equity is some important thing for me.
Yeah, and for me, it's one of those questions that you always hear, what can I do for the oceans? I mean, it's so big. What can, as an individual, you do? So it's a tricky one to answer. And I think, having been in sort of ocean conservation for sort of 15 years, the one thing I learned is we need new thinking, and we need business thinking a lot of the time. We need different approaches. Often it is just this same community that's trying to sort of make change, but we're not getting the big ideas coming in, and we need to attract that. And so as individuals, I think it's bringing the skills that you've got that are missing. It's not about trying to do the usual track of ocean conservation. It's bringing in something new, and then bringing an army with you. So working for companies, it's bringing that company, or it's bringing the organisation you're in, rather than trying to tackle this as an individual, because you're not going to make a huge difference usually.
So I guess I'm still, I'm wondering, Richard, from your perspective, as you work to communicate how we need to get over this ocean blindness, how we move forward, I think one struggle that those of us who are trained in science come with is, well, maybe twofold. One is we're trained to look at the facts and the data and not believe, and I think sometimes that translates to being reticent to advocate because it's expressing an opinion about something. And we're also not trained communicators. We're trained in other ways. And I'm wondering from your reflections, what role do you see for scientists as communicating the importance of the ocean, for advocating for conservation, sustainability policy changes, things like that?
Well, I do think it's absolutely critical, but often scientists need help from the communicators.
We need you.
Communicators that really understand how to communicate in a way that's going to engage people on a level that they can understand. So, yeah, we've been developing an Ocean Communication Academy to teach really sort of more marketing skills as opposed to communication skills. Traditionally, we focused on communication, but communication leads to awareness that then gets forgotten. It doesn't lead to action. Marketing leads to action. That's really what we need to be doing. So looking at projects from the outset, making them really engaging, and really communicating optimism. Often we're so focused on doom and gloom when it comes to the ocean. We're not seeing the potential and seeing the potential of the ocean. And if you start getting people excited by that potential, things change very, very quickly. And so I think there's lots of potential here.
Mm-hmm. Would either of you like to reflect on that?
I was just trying to think about how I can use Richard to help me promote my organization's messaging. Remind us your question.
Well, the role of scientists in advocacy,
Yes.
and in communicating that in community engagement for making change.
I mean, I like you, am a trained scientist, so I also, I went into this field thinking, well, if we just figure out all the facts and we can tell it really convincingly because there's the data, obviously everybody will do, the right thing. That I'm still kind of recovering from that because it just seems like it really should be true. But I started my PhD during the George H.W. Bush administration when there was kind of a battle about, scientific theory, and evolution was being, challenged as a theory because it was the colloquial definition of the word. It was just theoretical. Evolution is just a theory as opposed to the scientific definition of theory. And now we're in this world where reality itself is being questioned, not just science, right? So it really is a whole new landscape, and I think Richard is right. You just have to believe in your ideas and market them, rather than rely on data and science. But I will never give up on science and data, and I think scientists and people who do seek truth, you don't have to have a PhD in science to kind of be able to read a paper and kind of understand truth from fiction, have a huge role to play and in terms of advocacy. And I think the role really is making yourself available to journalists, to NGOs, just making yourself available to be able to speak in public and kind of get out of the lab.
An extraordinary privilege, luxury of being at a place like Columbia is you have colleagues. And what I have the path I've taken is trying to be a little bit more open and inviting of people whom I would normally not ever interact with to go and play with them. So right now, we have meetings where I talk to a historian and an anthropologist about these topics. So, I can continue to work in my lab and try and get that third decimal, fourth decimal accuracy of whatever measurement I'm making. That's not where the problem is. And so the question is, how do I transfer what I do? And I do okay, I think. Okay, I do it all right. What I do, but how do I make that more relevant? And for me, I find some satisfaction in talking to a historian to get a sense of the scale of the problems I'm dealing with, the background of the people that I'm working with, talking to an anthropologist. So for me, it is really trying to expand what I do through the lens of others, through the experience of others, and seeing if that will make the difference. We are at a place, for example, with the changes that are going on in the ocean. I will continue to argue with my colleagues as to whether the third and fourth decimal point number is correct or not. That will go on. But there is no doubt about the first decimal place. And so we don't need to involve the entire population in that argument about what's going on in the third decimal place. We need to be talking about what's the number before the decimal point or at the first decimal point. And for that, we need help of other people. And so for me, it is just a matter of expanding the number of people that I talk to make the message bigger. It gives me personal satisfaction because it makes my understanding fuller as well, richer as well.
And one thing I love is sort of talking to all the scientists at Woods Hole. You never meet a scientist who's not excited about their work, but when they're talking about it, they really share that excitement. And yet, people connect with people. They don't connect with science generally. So if they share that excitement, suddenly you're hooked, and then suddenly it sinks in. And that's really what I think we need to be working on. Is just getting science community to be as enthusiastic in public about their work and excited about their work as they are in private.
Mm-hmm. There's a wee bit of embarrassment that comes out of that, right? Because I know it's just one of those things where, when I tell somebody that I used to wake up at 6 o'clock in the morning because I wanted to get into my computer and look at those numbers again because there's a pattern out there, I can see it, and I work at it, and I get paid to do it. It's for me almost like an ultimate, again, go back to luxury, that I actually get paid to have the fun that I'm having, right? People don't believe it. Or, and it's the context, right? It certainly seems like a privilege and a luxury to be able to say that because a lot of people don't have that. But you're right, it is like, this is how my day goes every day.
Yeah, and it's infectious when you hear it, that someone's really passionate about really quirky science often. But then you get sucked into it yourself. And I was talking to someone who studies prehistoric bones from, I think, anglerfish to work out fish populations and the impact of climate change on fish populations. And these things are kind of like 0.5 millimetre, and she's there separating them all day. But when she talks about it, you just go, wow, we can find out so much more about climate change and the impacts on fish populations, which isn't what we expected. And suddenly you're sucked in, and you just need that enthusiasm coming out.
One of the things that my colleagues and I think about a lot is this framing around ocean science literacy and thinking about just that appreciation and basic understanding for the ocean. It kind of intertwines with ocean blindness a little bit, I think, but one of the things that we're doing is trying to do what they call a landscape study to understand how much ocean science is actually taught at the middle school level, at the high school level, nationally, and what some of the barriers are if it's not being taught. Because, I'm biased, but I think the ocean is, what makes the Earth habitable. We need to understand how it works and appreciate ocean life. And by starting early and having that conversation, I think we will all do better in the future.
And I'd love to do a campaign on that. What was it? UNESCO put out a call saying all countries should have ocean science on their national curriculum. Not one has. In the world. And you go, that's staggering when you think of the importance of the ocean. And so just raising awareness of this lack of ocean literacy, this ocean blindness, I think, and then getting kids to demand it would be a great start.
I don't know if there are any teachers in the audience here, and my information is about 10 years out of date right now, but it is something that I looked into, and New York State education standards do not include oceans. You have geology, but you have rocks, but you don't have oceans. Given, if you think of, from where we sit to right now, it has a long coastline. Long Island goes out 100 miles, 150 miles, and comes back 150 miles. That's a longer coastline than many other states have, and yet we don't have oceans in the New York State standards, which means getting this ocean literacy into schools, which is where it really should begin, is going to be really difficult because the state standards don't work there. I have the fortune of working with a science teacher in Alaska who actually is from the Marshall Islands, and he did a minor in marine biology, so he's really enthusiastic about it, and he sneaks it in to his environmental science program. It's not actually allowed to be taught as an ocean science by itself. However, there are, I just want to, I don't know, it's a put a plug for, but there are ways, right? I mean, so I'm working with high school students there, and we have low-cost devices. And there's actually a professor at Stanford who has this as his mission, and there are many other people like that. And so it's not just that he's unique, but he basically wants to make low-cost instrumentation that allows everyone to be a scientist. So he was the person who invented the foldscope, which is a $1 microscope that you can basically print, and he made tens of thousands of them and distributed them around the world. So anyone who's curious can actually put a sample and look at it under this microscope. He has made this, his lab has come up with this thing called a planktoscope, which is the device that I work with the students in Kotzebue, where you can take a water sample and look at what's in the water in terms of microbes on your phone or your iPad or whatever. And so I think to the point of how do you sort of increase literacy, it is actually perhaps looking for ways in which you empower people to go and explore the environment for themselves, in addition to whatever else they can learn in a classroom.
I love that, yeah, and it's so important in terms of the state standards. In fact, the pilot that we ran for this survey, the two biggest barriers to teaching ocean science, and most of the respondents did not teach ocean science, were state standards and full curriculum. So there's work to be done in that space. I like to think of, can we get in cryptic ocean science, so where you use marine examples to illustrate core concepts in terms of ecosystems or photosynthesis. We just, again, ocean blindness, we think about terrestrial examples because we are terrestrial creatures. But if we got a little more cryptic ocean science in there, maybe it'd be a way to start.
I always think about the first, I had to wait till the first year of my PhD program to learn anything about oceanography, and I could not believe that I was being taught, how the earth turned and how weather is formed and why the sky is blue and all these like very essential questions that every little kid asks. I had to wait until I was in a PhD program to suddenly kind of understand how my whole world worked. And so I don't think you have to live in a coastal state like New York. I think 1 out of every 2 breaths that we take comes from phytoplankton in the ocean. So it's insane. It's really insane that we do not teach this in America, for one thing, or anywhere. I'm on board.
Yeah.
Well, I think that's actually a great segue to a final question. We've talked about how the ocean is changing and some of the really hard parts of thinking about life in the ocean and the challenges around conservation, sustainability. So to end, let's just go back to that sense of wonder that you've heard today about the ocean, and maybe each of you could just share one quick aspect of wonder that you carry about the ocean that you'd like to share with everyone.
Well, for me, I think it was it wasn't even a dive, it was just a swim. But I've been out to sort of the middle of the Pacific, and there you learn from sort of ancient Pacific kind of voyagers. That there are 2 oceans. That there's the ocean you see from shore, they call sort of Moana, and then there's Kai, the ocean beyond the horizon, the real ocean that we're related to, the all-powerful. And we kind of think about the Moana as opposed to Kai. And when you go over that horizon, you get out into the open ocean, and you suddenly get away from a boat. We spotted a bait ball on the horizon, and so we went away from the big ship on this little Zodiac. Got there, everything had disappeared, but we thought we'd get in the water anyway. And you jump in the water, and it's 4 miles deep, and you're watching this light getting sucked down, and everything is moving, and you just feel the energy. And it just gets you at your core. and you realize there's this just whole other world out there that we never think about. And that was just really sort of mind-blowing for me, this effect it had on me getting out to the open ocean. And you wish more policymakers would do that, and actually the ones making the decisions about the high seas would get out to the high seas and jump in the water.
It gives me chills to listen to you talk about it.
I have a good segue there. So like I said, I grew up swimming in swimming pools in New Jersey, and then sometimes in the summer we would go to the Mediterranean, also coastal Mediterranean, where nothing was growing. I don't think I saw one fish in 15 years going swimming in the Mediterranean Sea, and then sometimes off the coast of New Jersey. So all these places where it was just really, for me, it was really all about swimming, being in the water, feeling that water on me, and swimming as fast as I could. That was my existence. And then one day, I am traveling in my early 20s, and I am off the shore in Egypt, and everyone else is just sitting around, smoking, eating pita, having a good time, but I can't help myself when I'm near a body of water, and I'm like, nobody's going in the water, it's right there. So I go in, and it's just a bunch of travelers, and I go in, I put my goggles on, I'm going for a swim, like that's what I do. I go in the water and I go for a swim. I go in, I put my goggles on, I swim like 2 strokes, and I'm on like an incredible coral reef in the Red Sea. This is like 1994 or something, so the reefs were still beautiful then. And I had no idea coral reefs existed. I was 19 years old, and I was just used to literally seeing the bottom of a swimming pool. That was what I was used to. I did not know that much life was like humanly possible coming from the suburbs of New Jersey. I like tread water, I look around, I see everybody on the shore just chatting. I was like, do they know what's happening down here? And I like put my goggles back on because I could not even believe what I saw. I was like, I must have been dreaming. Let me do this again. I go in, and then I could only last like 5 minutes speaking about that energy. It was just like, I felt like I was gonna pass out. I had no clue that any of that was possible. And that was my first coral reef experience.
That's awesome.
And on a positive note, that reef sort of in Egypt is one of the least vulnerable to climate change. So it is one of those places that we can still protect.
Yeah.
And we went out there for the COP, and it's still in great condition. And it's one of those hope spots when you get in the ocean.
Ajit?
I was on a research vessel off the coast of California in the Channel Islands. We call them cruises. Please do not confuse them with cruises, but that's, it's going to come out of my mouth no matter how carefully I try to talk about research expeditions. And this is an old ship that doesn't exist anymore, that isn't working anymore, but it is one of the 2 ships in the US fleet that actually had a bow chamber. This is basically a glass chamber on the bow of the ship just below the waterline. And they built these ships in the 60s when, I guess, they did things like that. But in any case, the ship had a bow chamber. To get down to it, you had to go down 3 decks, and they're all watertight doors because this is a pretty vulnerable thing to have a glass bulb in the front of the boat and the bow of the boat. So you kind of have to go through a whole bunch of watertight doors to get there. It's not trivial, but it was a place I could get away. Research vessels are pretty tightly packed. So you actually want to get away from people. You got to kind of try a little hard. So I had to go down these 3 decks with watertight doors to get away from everybody, but I've heard about the bow chamber. I went down there, and I've done that a couple of times, and this particular time I was there at dusk. Just before, I'd finished all my work. I had a few hours off before my next sampling, so I went in there. And it's a very narrow, it's maybe about this high, and the way you get into that is you lie down. And there's a pretty skanky mattress that you lie down on, but you're going to crawl into that space. But then you're in this glass chamber where you have glass all around, so you can see basically around you. And I was just lying there, and we had come on station, so the ship was basically standing, and it was bouncing up and down, and you can see the waves breaking, and the sun was going down. And then it got dark, and then I heard like a squeaking noise. And immediately my thing was rats. And, it's like you cannot get out of there fast enough. And it's like, I don't want to be with rats. But then I saw this movement of the corner of my eye, and there were these dolphins. And they had come on, and they were basically playing in the bow wake of the ship. And so they were swimming along with the ship as we were going, and as we were moving. And then I saw them starting to light up. Like it was dark outside, but then the dolphins started having color to them, and it was bioluminescence. And bioluminescence, you basically is called, in this particular kind of bioluminescence, it happens when there is turbulence. And the actual movement of the dolphins basically causes the skin of the dolphin to have the turbulence. So they basically were lit up like the shape of the dolphin. It was absolutely amazing. And it's sort of almost pitch black, and then you have these magical, lit up dolphins swimming along with you. I don't do dolphins. I mean, when people talk about marine biology and dolphins, it's like, no, that's not me. I do microbes that you cannot see. In this case, the microbes that you cannot see were lighting up the dolphins that you can see. I like that.
The ocean is a thing of wonder.